In step 4, we'll perform vector proximity analysis by calculating statistics for attributes. First, we'll use Explore Statistics for the island's SQMI field. Then we'll use the Visualize Statistics for the island's SQMI field. And last, we'll summarize statistics for the trails using the name field and summing the total feet. Back in ArcGIS Pro, I'm going to right-click on the island's feature layer and select Attribute Table to open up the Attribute Table. And then in the Attribute Table, we want to calculate statistics for the SQMI field. And so we'll begin by right-clicking the SQMI field, and we're going to select Explore Statistics, which is going to open up data engineering for the islands fields. I'm going to go ahead and reposition my table views so I can see both. And you can see in the data engineering view, it lists all of the fields, and then shape is bolded. So it's showing me the statistics for the shape field, including the distribution, but also basic statistics and more advanced statistics that describe the distribution curve. We can also calculate statistics by looking at Visualize Statistics. So I'm going to right-click on SQMI again, select Visualize Statistics, and this opens up both a chart view that shows you the normal distribution of the values in the SQMI field, same as in the chart preview and data engineering, but also all of the statistics. So over in the chart properties pane, if I scroll down, I can see all of the same statistics that are visible in the data engineering view. Now, is one better than the other? Not necessarily. It just kind of depends on what you're used to and what you want to work with. All right, go ahead and close the chart properties pane, the chart view, the data engineering view, and the islands attribute table. And now we're going to open up the trails feature layer attribute table. And this time we're going to summarize the total feet by trail name. So we'll start by right-clicking on the name field and select Summarize. And in the Summary Statistics field, the input table is set to trails, the output table to trails statistics in the geodatabase. We're going to set the field to feet and the statistics type to sum. So we want to sum the total feet for each case in the case field, and that we're going to use the name field for that. Click OK. And that creates the standalone trails statistic table. I'm going to go ahead and right click and open that, and then position it side by side with the trails table view. And there you can see the trails table view has 7 records and the trail statistics has 5 records. And that's because the trails table view has 2 Indian path records that are combined into a single record in trail statistics and the total feet summed. The same for Crocodile Creek. I'm going to go ahead and clear the selection in both table views. And then in the trails attribute table, I'm going to right click on feet and sort in descending order. I'm going to do the same in the trail statistic on some feet and sort in descending order. And so now we can see which trails are longest. And in both views, the Lost Boys Loop is the longest, but in the trail statistic, the Indian Path Trail is the second longest trail on the island, and that's because the 2 segments are combined and their feet summed to get a total length for Indian Path. All right, go ahead and clear your selection, close your table views, save your ArcGIS Pro project. In step 5, we'll perform vector proximity analysis by calculating geostatistics for our features. First, we'll calculate the mean center of the site's feature class, then the median center, and last, we'll identify the central feature for the site's feature class. Back in ArcGIS Pro, we can perform geostatistical analysis by clicking on the Analysis ribbon and then the Tools button. That opens up the Geoprocessing pane. I'm going to click on the Toolboxes panel and scroll all the way down till I find the Spatial Statistics toolbox, click on that, and then scroll down again and click on the Measuring Geographic Distributions tool set. And in that tool set, we'll find 3 geoprocesses we're going to run: the mean center, the median center, and the central feature, and we'll compare the differences. We're going to start with the mean center. So go ahead and click on the mean center. That opens up the mean center geoprocess. For the parameters, we're going to set the input feature class to sites, the output feature class to sites mean center, and that's going to be stored in our demo geodatabase. Go ahead and accept the rest of the defaults and click Run. And that creates a sites mean center point feature class and lists the sites mean center feature layer in the contents pane. Now notice it's not in the map view. That's because if we zoom out, we'll see it's to the north of the island. And the reason for that is if I right click on the sites feature layer and select zoom to layer, there's an outlier, and that is the sites include a site in London, and that's included in the overall average. I'm going to zoom back to my islands by right clicking on the islands feature layer and selecting zoom to layer. Now in statistics, we like to lessen the impact of our outliers by using the median rather than the mean. So I'm going to go back and click on the median center geoprocess, set the input feature class to sites, the output feature class to sites median center, accept the defaults, and click Run. And that calculates the median center, which I can see in my contents is a yellow dot, and I can see it located on my map as well. And if I open up the attribute table for the sites, the median center is calculated by finding the median value of the x and the median value of the y coordinate, and then combining those to create your median center. All right, the last geostatistical process we're going to run is central feature. So go ahead and click back and find central feature and click on that. Set the input feature class to sites, the output feature class to sites central feature, the distance method to Euclidean, accept the rest of the defaults, and go ahead and click Run. Now the central feature and the median center are similar, but they're not the same. And if I click and drag the sites layer up to the top, I can see that the central feature is always coincident with the central feature of the feature class for which you're calculating it. All right, go ahead and close the geoprocessing pane. Reset your map view, save your ArcGIS Pro project. In step 6, we'll perform a vector visual proximity analysis by classifying features by symbol. First, we'll symbolize the trails by single feature. Then we'll symbolize the trails by graduated colors. And last, we'll symbolize the trails by unique values. Back in ArcGIS Pro, we'll begin by turning off our geostatistical point feature layers and then selecting the trails feature layer. And on the context sensitive feature layer ribbon, click on the symbology drop-down button and select single symbol. And that opens up the symbology pane. I'm going to go ahead and dock it over my catalog pane, and then I'm going to click on the symbol patch there to update my symbol. And I'm going to switch it over from brown to pink, and you can see it updates the symbology for all of my features because it's one symbol for all the features, and that's reflected in the contents pane as well. Now, the straight line doesn't necessarily represent my symbol patch, and so I'm going to change my symbol patch by clicking on the drop-down button to the right of it, and I'm going to select a different symbol that looks more like my features. So I can see a little squiggly line there, and it's reflected in the contents pane as well. All right, now let's try visualizing our data in a different way. So on the primary symbology in the symbology pane, I'm going to click on graduated colors and then set the field to feet. Go ahead and leave the method and classes set to the default. I'm going to update the color scheme to be something that's going to really stand out, cyan to pink. And there you can see it's symbolized all of my trails by trail length. And my shortest trail segments are cyan, and my longest is hot pink. or magenta. And if I click on that longest trail, I can see that it's the Lost Boys loop. All right, go ahead and close the pop-up window. Now let's visualize our data one more way. So under primary symbology, we're going to visualize it by unique values. Set the field 1 to name, the color scheme to a set of brighter colors. And then there's no values listed there. And so before I do anything, I want to go ahead and update the symbol patch to my little curly trail symbol. And then I'm going to click on the Add All Values buttons. And that adds all the unique values in the name field. And I can see them listed there and also in my legend, as well as in all other values, which I don't want that because that's like null values or values that aren't listed there. I don't have any, so I'm going to click on More and Show All Other Values, which is going to disable Show All Other Values. And you can see it doesn't show up in the contents pane either. All right, go ahead and close the symbology pane. Reset your map. Save your ArcGIS Pro project. In the previous step, we used symbology to classify vector features. In step 7, we're going to use dissolve to reclassify vector features and perform our vector proximity analysis. We'll begin by opening the dissolve tool, setting islands as the input and islands dissolve as the output. Then we'll dissolve the trails feature class on the name field and set the output feature class as trails dissolve. Then we'll explore the islands dissolve and trails dissolve features and attributes. Back in ArcGIS Pro, I'll begin by opening up the islands feature layer attribute table and noting that in the table there's 14 records. So there's 14 features in my map view and 14 records in my table view. Now I'm going to reposition my map view so I can see Skull Rock on the north side there. Activate the analysis ribbon and click on the tools button to open up the geoprocessing pane. And then in the search text box, I'm going to search for dissolve and then right click on the dissolve item and select locate. And that's going to locate that tool within all the toolboxes. I like to do that so I can see where it is, and often I can see tools near it that I might find useful. This is in the data management toolbox in the generalization tool set, and there you can see dissolve. So I'm going to open up dissolve. It includes a pairwise dissolve message that says you might have enhanced functionality or performance. That's if you have a lot of features. We don't have that many, so we're okay. I'm going to set the input features to islands. The output feature class I'm going to leave set as islands_dissolve. I'm going to accept all the rest of the defaults, including enable create multi-part features, and then click run. All right, there I can see my islands dissolve feature layer in the contents pane. I'm going to right click and open up the attribute table and stack those side by side. And then in the contents pane, I'm going to click on the list by selection panel and make sure that islands is the only selectable layer by right clicking and selecting make the only selectable layer. All right, so now when I go to the map ribbon and click on select and I click on Skull Rock, it selects just Skull Rock, which is one out of 14 features and records. And there you can see the features selected in my map view and the records selected in my table view. Go ahead and clear the selected features. And now I'm going to switch to make islands dissolve the only selectable layer. And when I select Skull Rock, it selects everything. And that's because when I dissolved it, it created a multi-part feature that merged all of the features and records into a single feature and record. Go ahead and clear my selection and close my table views. Reset the contents pane by turning off islands dissolve and listing layer by order. And then I'm going to go back and run the dissolve tool again, this time on the trails feature layer to an output called trails dissolve. My dissolve field is going to be name. My statistics field, I'm going to set to feet and my statistics type to sum. Go ahead and leave Create Multi-Part Features checked and click Run. Now I'm going to open up the attribute tables for the Trails and Trails Dissolve feature layers, stack them side by side, close the geoprocessing pane, and you'll see there's 7 records in Trails and 5 records in Trails Dissolve. And that's because, again, Indian Path is 2 features and records in Trails, and it gets dissolved into one single feature and record in Trails Dissolve. And the same for Crocodile Creek. And so if we clear our selection and then right click on feet and sort in descending order and do the same for Trails Dissolve, right click on some feet and select sort in descending order, we'll see again that the longest trail is Lost Boys Loop, but the second longest trail in the Trails is 5.0, but in the Trails Dissolve, it's Indian Path, and that's because the 2 segments are combined into a single segment with a sum that is longer than the 5.0 trail. Go ahead and clear your selections, close the table views, uncheck the Trails Dissolve, reset your map view, and save your ArcGIS Pro project.